Hi, I'm Chris Littlewood. I work for Filtered. We do online training in essential business disciplines. So we have courses in project management, Microsoft Excel, leadership and management, communication, that sort of thing. The thing that really sets us apart, the thing that makes us different, is that we try and teach our students just what they need to learn. And by that we mean that we strip out things that they already know, and we strip out things that aren't useful to them. So the stuff that's in the course content that isn't immediately relevant to their job, how they want to apply the training. And we do that stripping out with an algorithm, which we call the filter, hence the name. We've been developing this since the business started, but we put a lot of effort into it last year. And what I want to talk about is some of the things that we found as a result of that journey. So we think that online training is on the verge of a revolution in terms of personalisation, and that over the next year, 2 years, more and more online training is going to be personalised because it makes it more effective for the user. So I want to say a little bit about our approach and a little bit about the sort of general principles that we think you might want to think about when applying an algorithm to online training and producing a personalised course. But first of all, so training, I think, is on the cusp of this transformation. But algorithms are used in many fields. Wherever there's a web-based service, then there's a lot of data, a lot of user data. And so there are quite a few sectors where the use of an algorithm is more mature. And I just wanted to talk about those first. So first of all, I'll cover the uses, then I'll talk about us, and then I'll say hopefully something that's relevant to everyone who's thinking about going in this direction. So first on to the uses. So here are some examples, well-known examples, of businesses that are online and that use algorithms. So these do a wide variety of stuff. So there's Shazam, they use an algorithm to recognize music, recognize tunes. Amazon, who are using an algorithm to predict what you're most likely to buy from them next. Quantopian, they do financial trading algorithms. So it's looking to make money on the markets by spotting when to invest, when to make a trade. Down the bottom here, we've got an example of facial recognition. So this example is iOS. There it's using computer code to try and identify features from a face in order to recognize which individual the face belongs to. So Boxcryptor up here, that's what they do is security. So they encrypt information so you can transfer it to and from the cloud. So they make cloud-based internet services secure. Perhaps most famously of all, Google. So Google's algorithm is famous enough that people know its name. Their algorithm PageRank, which is used to classify websites, prioritize them in terms of a sort of proxy for quality. And then at the top there, Newton. So this is taking a step back towards training. So probably many of you will be familiar with their name. They're pioneers of application of an algorithm to training, particularly for students at school or in universities. So these are algorithms doing a wide variety of things. Some of them have a long pedigree of doing it in their industry. And they're doing very different things, but three of them in particular are doing something that's really applicable to what we want to do with content in training. So here, Amazon, Newton, and Google, what they're interested in is ranking content, in trying to select content that's most appropriate for an individual user. So I just wanted to talk a little bit about those, and so the things that we might learn from them in developing algorithms that for our own use in training. So first of all, Google. So this schematic on the left-hand side here. So what's this? The blobs represent websites. The arrows represent links between websites. And the size of the blob is the PageRank algorithm's quality estimation. And the way this works is it's based on number of links, and it's based on number of links from sites that also have a lot of links. So it's iterative. There's a few stages to it. But you can see the big red blob has a lot of links, and it's also got a link from the important blob E, which itself has lots of links. So what's the relevance to training here? There are links between bits of training content. But if you look at what people have done in training, so if you look at Newton, for example, then they've basically got a similar thing that's like a link. What they do is they use tagging so that they know they've got a framework for content, and they use their students as the link. So if I use two pieces of content and consume them, and I learn from them, then I'm forging a link between those, and that can be used to make inferences, and you can take something that you know about one piece of content and transfer it to another. So that's Google. Amazon is doing something on the face of it more simple. So these are my recommendations from Amazon at the moment. And the point I wanted to make here was really one that is about simplicity. So this is based on actually just one purchase. So it's recommending that I buy some microscope slides and a book on microscopy. I bought some microscope slides because I was giving a talk in a school. I've only made one purchase of that sort. I've made hundreds of purchases from Amazon. So on the face of it, this is really naive. But the point I wanted to make here is that this prediction might well be good enough. The thing I'm most likely to buy next might be exactly the thing I've just bought. I might want two of them, or it might be something very similar. So the takeaway for training is that we shouldn't get lost in the sophistication. That sometimes you can do something really effective, really simply. This is a schematic. I mentioned Newton when I was talking about Google, but this is a diagram taken from Newton's own website, and the blocks represent pieces of training, and the lines are links between those trainings, those bits of training. Those links are forged by, as I said, student experience. So if I do well with a piece of training, and I do well with another piece of training, then maybe a similar student to me will benefit from those two learning types. So that's just an overview to give you an example of how algorithms might apply in our sector. And now I want to talk a little bit about our own approach and what we've done. So as I said at the start, we do online training in essential business skills. So that's and please, by the way, come and see us at our stand and talk to us about that. We're just down there, around the corner, stand 27. I'll be there after the talk as well if you've any questions about anything. This is what our content looks like. So this is an example of a module. So we break our content down into modules. They're text-based, video-based. There are exercises. There are graphics. So it's a mix of content types. But the thing I want to point out on this slide is over on the left, where you've got the little grid of blocks, and that's the modules for this course. So this course is communication, influence, and teams. So the student here has answered some questions about themselves, covering what their job is, what tasks are important to them in the performance of that job, how confident they feel with those tasks, and an objective assessment of how good they are with some test-style questions. So it takes them that filter. Set of filter questions, as we call them, takes them 2-5 minutes, something like that. And then they're presented with a filtered course. And that is what you see on the left-hand side here. You've got a set of modules. The white ones are things that we recommend that they study. And the grey ones are things that we recommend that they skip. And we'll be recommending that they skip them because we think they already know them, or it's something that's not really applicable to the way they want to apply this training. So what this is showing is, again here we've got some squares. These are bits of content, modules in our course, for instance. So the first thing we're trying to do is assess whether the student knows them, or whether it's new, whether the stuff is new to the student. So here we've got an assessment of these, whatever it is, 5 modules. Over on the right-hand side, we think this module is really likely to be new to the student. Over on the left-hand side, we're pretty confident that they already know it, and the others are in between. That's the first stage of our assessment. The next stage is to assess whether that's something that's relevant to them, so whether it's something that's going to be valuable to them in their work. And you can see that we're starting to build up a picture of what a training course for this student should look like. And we quantify that. So what we actually assess is the likelihood of each of these these things. So we assess how likely it is on the over here that the stuff is new to them, and we assess how likely is it that it's something that's useful to them. And then we can combine those to give an overall likelihood that they need to learn this thing. So here you can see that the red dotted line is a cutoff. So we're saying the stuff above the cutoff is stuff that for this student, it's really likely that they need to learn it. So we can present just those 3 modules. So in this example, we'd have cut the course by 50%. We've halved the time that they have to spend on the training. We've given them stuff that's more relevant. And we've shown that this really works. We undertook a study in the summer, and we compared a group of students who followed a filtered program compared with a group of students who followed an unfiltered course, just were presented with the whole course and found their own way through the training. And we saw a 26% better performance between before and after testing in the filtered group. So not only does this save people time, but it actually trains them better in the end as well. I'm just going to, so that's overall what the filter does. I want to say a little bit about how it does it, and I'm just going to focus on one of the 2 dimensions for reasons that, well, mostly for time reasons. So first of all, how do we assess, what does it look like when we assess the extent to which someone knows something that material is new to them? This visualization is just going to show what happens if I, as a student, come to our site and start answering questions, filter questions, to tell Filtered a bit about myself. So across the way, the green and yellow bar at the top, that's showing all the modules in our project management course. And we're assessing the likelihood that this is new stuff to this student. So this is at the start. We don't know anything about this student, so we're just assuming that they're average, that they're at the average based on all of our usership. So it's subtle, but there are little differences here. So green means that the student already knows the stuff, and yellow means that we're a little bit less certain that they know it. It might be new. We start asking them questions, and the changes, there's not much change at first, because the questions we're asking in this stage are mostly about the value of the material, not their knowledge of it. But as we get onto the knowledge questions, which we're about to, you start to see real structure in their course. So as they go through it, you start to see these blocks of red appearing, the clumps of red modules, and those are things that we think are really likely to be new to this student. So as we get down, by the end of it, we've got a really stark distinction between stuff that we think the student should focus on and stuff that they shouldn't. We take that, at the end of the filter, we take those likelihoods and we combine them with the need to know likelihood. So as I said before, then I'm only really going to go into this axis, the horizontal one at the moment. And that, so this is based on Bayesian statistics. We just take appropriate account of each new bit of information as a student answers the question. The vertical axis, when we're typing students as to what are their knowledge needs, what do they need for their work, we do that with a clustering algorithm because we've seen that students tend to fall into types like a beginner, an expert, or a particular sort of specialist. So we end up, at the end of this process, we end up with this assessment for all of the training modules. So we'd have whatever it is, around 60 dots on our graph, and we'd be able to apply a cutoff and say, here you go, this is a course which has been selected for you, it's appropriate to you, and doesn't have anything in that you don't need. That's about us. What I'd like to do now is try and draw some things out from that, from our experience and from that, the way that the decisions we've had to make, and try and generalize them so that there are some useful things to take away if you're thinking about personalizing content yourself or working with someone who can do it for you. So the first principle for applying algorithms to training in particular is evidence basis. So this is the sort of bread and butter. It's right at the heart of what we're about, and I think it should be right at the heart of anyone who's using this sort of approach should be thinking about. So the decisions that your algorithm makes need to be based on real data. If you without that, then you can't be certain that it's not supported by real usage, and you just can't be certain that you're not making mistakes. So the other thing to mention here is that this data is really precious. So we've got a lot of students. We have 600,000 students, and we have a really tightly defined, focused set of content. So we've got really rich data with which to support our algorithm. But even in that case, sometimes we have to work really hard to wring the most out of the data and make sure that we're understanding everything that we can about our students and applying it to the way that the algorithm works. Having said that, the data only takes you so far. Like I say, in our case, we're quite data rich, but in other applications, that might not be the case. And there, you have to be really careful that you're not making incorrect or unhelpful recommendations to a student because you're solely reliant on the data. You need a picture of the student as a whole. You need to make sure that the recommendations that they're given make sense as a whole. So this is about understanding individual users instead of your users on aggregate. And it's about really working to build up a picture of them so that you can sort of model them and you can intuitively understand whether your results are sensible. This next one, supplementarity. So what I mean by that is that when a student comes to training, then they've already got their own ideas about what is useful to them, and those ideas are extremely valuable. You need to be careful that your recommendations don't supplant or override that insight. So everything that the algorithm does should make the user's experience better. It shouldn't be about throwing away all of that insight that they bring to the table. And you can do this in lots of different ways. The way we do it is by making the filter recommendations are there, but the rest of the course is accessible. It's easy for a student to say, actually, I don't agree with your decision here, I'm going to override it. And we take account of that. That part of that process is part of how we improve the algorithm for future students. The next point I wanted to make was about transparency. So if you're coming to a set of recommendations, so if you take the example of Amazon, so they're recommending me some microscope slides, I can instantly make the decision whether that's a sensible purchase for me. It takes none of my time. But with training, then usually I'm training because it's in an area that I'm not overly familiar with. I'm investing some time into it, so that decision is a big one. So trust is really important, and the students need to trust the recommendations that the algorithm is producing for them. And I think a big part of this is being transparent and explaining how those decisions have come about. Going back to what, our journey and what we did in developing our algorithm. So we could have taken off-the-shelf machine learning algorithm, trained it with our user data, and used that to make recommendations to students. And that would have been fine. I'm sure the results would be similar. But the problem with that approach is that it's just not transparent. We wouldn't be able to explain those to users in a clear way. We wouldn't be able to say what was the effect of an individual filter question because it would just be meshed up in the machine learning algorithm. It would take a lot of analysis for us to unpick the recommendations and explain what was happening. So we wanted to make things really clear, so we can say to a student, you're in. If they want to understand the results of the filter, why they're in a particular group, what effect the questions had, we can set that out clearly, as in the visualization that I showed a little bit earlier. So the last principle that I want to draw out is acknowledge uncertainty. So this isn't a cop-out and saying that the recommendations won't be perfect. What this is saying is that it is really useful information to the student if you can tell them how confident you are with your prediction. So when we make those predictions, if you think back to the graph with the blobs on, so sometimes we can be 95, 99, 100% confident that a piece of training is going to be useful to a student. Other times we might be recommending that they take a piece of training that there's only 80% likely that they need. But that information is really useful to the student in discriminating between those bits of training. So I think this is something that has general application. Give the students that information so that your recommendations are supplementing their own assessment as to what's useful and what's not, rather than cutting across it. Okay, thank you very much for your time. It's been really good.